Hi, everyone. Thank you so much for joining us. We're going to get started here in a few minutes with our webinar on OSHA compliance regarding the silica laws that have come out last year. I ask that you all refer to the chat dialog box for any questions. We'll take some time at the end to go through the questions that you have, keeping in mind that we will be recording this and published on our website as well as the PowerPoint. But we're here if you've got any questions at all. My name is Megan Marshall. I'm the Sales Rep Training Manager for North America, and I'm thrilled to present Brent Willson. He's going to be our OSHA expert. He's the one we go to for all the technical questions, and so whenever you're calling me and asking, he's the one I'm asking the question to. So thank you all again for joining us, and take it away, Brent.
Thank you. So a little bit about me. I don't know, for some reason they keep giving me more titles. So I'm a project with research and development, the product and compliance manager with Dustless Technologies in Utah. Because I served 22 years in the Air Force, they figured that I knew a little bit about how to read government regulations. And so they handed me the compliance portfolio as well. So I've become somewhat of an expert in the OSHA Silica rule, EPA's Renovation, Repair, and Painting Program, EPA RRP. California's Prop 65 is my least favorite one, but we're not going to talk about that here. I have an MBA from Thunderbird School of Global Management, and this presentation is based on the one that I gave at the World Demolition Summit in Dublin, Ireland. So I took out some of the international stuff, but it's largely similar to that. A little bit about Dustless. You see the picture there? As you can tell from what just went by, right across the street from that picture is one of the main rail lines that run from San Francisco to New York. And so it's a small mining community in Price, Utah, and basically it started Colleen and Mike Lovelace decided that they needed to find a way to control the ash as Mike was cleaning out the fireplace, came up with the ash vacuum, and later on Mike invented a revolutionary type of HEPA wet-dry vacuum that was really ahead of its time. And just in the last few years with the Silica rule and the EPA RRP rule, where the government started regulating these hazardous dusts, we've sort of come into our own. So we've been growing quite well because for once the government has moved in our direction. This is just a little disclaimer. I am not an industrial hygienist. I am not a lawyer. And so when you're putting together your silica control plan, make sure that you get competent legal and professional advice on it. This is just sort of an overview of the Silica rule and the basic things you need to know to comply. So the Silica rule has actually been around for a while, but they really put some teeth into it in the last few years. And so the question is, why did they do that? I'm going to start with this story. As I said, we're in a small mining town. I have a friend, his name's Ron. Graduated from high school, a star football player, very athletic, as many young people did in his generation. The best place to get a job was in the coal mines. Worked in coal mines for several years. Over the years, he started noticing he was becoming more and more short of breath and not able to do the things that he used to like. He still loves the outdoors and everything else, but I met Ron because my son mows his grass because he can't do it himself, because he's attached to an oxygen machine. He's on oxygen, he has black lung disease. Black lung disease and silicosis that is caused by silica dust are very similar. In fact, black lung is in some ways a form of silicosis, especially in this area because the coal was in a lot of the sandstone. Crystalline silica is a respiratory toxin that causes silicosis. Silicosis is irreversible, chronic, and it's often fatal. It can lead to not only respiratory diseases, but also heart disease, kidney disease, lung cancer, all kinds of really not nice things. The silica rule, the new silica rule is intended to prevent over 600 deaths per year and 900 new silicosis cases per year. The way silicosis works is when you breathe something, you have what's called respiratory dust. Respiratory dust is the dust that your upper respiratory tract can't stop. It's usually smaller than I think it's 50 microns. It's smaller than you can see. And it gets down inside your lungs. And if it's something sort of biodegradable, your body will envelop it in a mucus and sort of just break it down. But as you know, silica is rock. So as it goes down, it sort of cuts things up. But then it just gets enveloped in this tissue, and it never goes away. And so it just gradually decreases your lung capacity. So
scary.
It's scary. Another reason for employers to follow a silica rule, one thing that we've noticed that a lot of people tell us, the biggest problem that contractors are having is finding good skilled labor. You need to take care of your workers, because if you're not making sure that they're safe and that they can be with you for a long time, you're going to be out there looking for them again. We have a company that we work with that he says, I have more jobs than I have guys to do them. So I have to turn down jobs. Take care of your workers to make sure that you can take advantage of the opportunities that are out there right now. So silica is one of the Earth's most common materials. It's found in sand, concrete, brick, natural and manufactured stone, glass, almost anything that has to do with rock, it's got silica in it. And as I said, okay, I stand corrected here, it's 10 microns is respirable dust. Normal human hair is 50 microns, so that's where the 50 came from. So it is produced by, respirable dust is produced by grinding or braiding. It's also produced by heat. When you heat up, for example, in sand casting, when they're casting metal, they use sand, and the molten metal heats up the sand and it breaks it into little tiny pieces. So when you break that open, it just releases all this really fine dust that gets down into your lungs. So it's really dangerous. So anything that breaks up the silica-containing materials can produce respirable dust that can cause problems. OSHA's final rule on silica, it entered into force in 2016, and it requires employers to control their exposures, employee exposures, and to train employees. So there are two main things that they need to do. It has two different standards, one for construction, one for maritime and general industry. The construction standard is the one that deals with most of our customers. Excuse me. It entered into force on September 23rd, 2017. The other one for maritime and general industry entered into force just this last September of 2018. Now, the difference between the two is if you are in a factory, like I said, a metal foundry, everything is sort of set. All your equipment is in one place, it stays in one place, and your procedures are generally the same. So they have slightly different standards that they need to live by. Construction, as you know, from job to job varies. And so you really need to be able to have a more flexible standard. The exposure levels are also important. And there are two levels. There's the action level, which is 25 micrograms of dust per cubic meter of air. And your permissible exposure limit is 50 micrograms. The action level means that if at any foreseeable circumstance, the silica exposures can rise above 25 micrograms, you are required to implement the silica rule. And that includes if the measures that the engineering controls, the ventilation, everything else that you have in place if that breaks down. That's got to be included in that conceivable circumstances that it might rise above 25 micrograms. 50 micrograms is the absolute upper limit. You're not supposed to have exposures higher than that. But that is also by a time-weighted average. So like I said, I gave this speech at the World Demolition Summit. If you've seen them, when they implode a building, you get a lot of dust. That dust only sticks around for about 15 minutes. So if the exposures over an 8-hour period average out to less than 50 micrograms, you're still okay. So now I'll get into that a little bit more. By the way, my little bee there, a bee's brain weighs 1,000 micrograms. So 1/20th, you're allowed to have 1/20th of a bee's brain in a cubic meter of air.
Wow.
So that just keep that in mind. That's the amount of silica dust you can have in a cubic meter of air. So your general compliance requirements, you need to have a silica exposure control plan. This basically lays out what sources of silica exposure you will have on your job site or in your factory, how you're going to do housekeeping, how you're going to control access to the area.
Yeah, just exit.
Sorry, we had a pop-up there. So how are you going to control that access to make sure that people that don't need to be there are not in the area being exposed to the dust, especially if they're not wearing proper PPE.
So this is geared toward the construction workers, the general contractors.
It's pretty much everybody.
Drywall, everybody.
It's also a factory. If that foundry is breaking apart molds, they need to make sure they have the proper ventilation and everything else, but the guys are probably going to be wearing respirators. They need to make sure that nobody can just come wandering through that area and be exposed to it as well. Gotcha. So you have to control access. You have to have signs and stuff like that to say, you know, there's hazardous, an exposure risk to silica, and don't enter. Okay. So you need to have, that all needs to be in your silica control plan, as well as it needs to be reviewed on a regular basis to make sure it still applies to conditions. Medical exams are required per the silica rule for any employee that wears a respirator for more than 30 days a year. And these need to be paid for by the employer. And they need to have a baseline exam within 30 days of leaving and when they, being hired and when they leave. And that's actually to protect you, because you take a baseline of when they get there, so you know where their lungs are then, and then when they leave. And so if they come back and try to sue you, you can say, well, this is where you were when you left. You weren't any worse when you came. You weren't any worse when you left. So that sort of covers you in future years.
Smart.
Now these exams need to be given every 3 years. And again, as I said, the cost is covered by the employer, and the doctor doesn't have to tell you what the result is. So there's all kinds of medical privacy laws that say you can't find it out. But you also need to cover what kind of training you're going to do. You need to make sure your employees are trained. If a OSHA inspector comes on site, they're going to ask them questions. You got to have a plan for your regulated areas, and you have to have what's called a competent person. Competent person is somebody who knows the rule, knows how to comply with the rule, and has the authority to stop operations if somebody's breaking the rule. And that goes for any OSHA law. They can be your OSHA guy, but if they come in and see something unsafe going on, they need to have the authority to stop all operations. One thing to point out is for general contractors, the general contractor is responsible for what all the subs are doing on the site. So if you have a subcontractor that is breaking the silica rule or any other OSHA rule, if an inspector comes on site and they will bust him, they will also bust the general contractor. So that competent person for this general contractor, any subcontractor needs to realize that if he comes in and says stop doing it, they need to stop doing it. And he needs to be able to have the authority to do that. Some more general considerations. Avoid visible dust. If you read the enforcement guidance that OSHA put out, one of the things that the inspector is going to look for is visible dust. So, you know, and actually, if he just happens to be driving by your site and sees a bunch of visible dust, he can stop and sort of see what's going on. Mm-hmm. And so, if at all possible, avoid visible dust. I mentioned regulated areas. They got to be controlled and limited access. Excuse me. They got to be marked off with signs. There's an example of a sign here on the slide. And PPE needs to be provided for anyone who has to enter that area. Area dust suppression. You can see here on the picture, they're tearing down a building there. They've got a spray truck. Sometimes, especially in demolition, you can't knock down all the dust. And so you'll see big sprayers that they use to suppress the dust from coming up and keep everything wet, and so you don't get a lot of the dust around. Confined spaces are a special concern. The more confined the space, the faster the silica is going to build up. So you need to make sure you have proper ventilation and proper engineering controls, PPE, and everything else to make sure you do it. Slurry is not directly addressed, but if you're using wet control methods like are often dictated, it will produce slurry. If you don't clean that slurry up, it's going to dry up and it's going to become an exposure hazard. People walking around on it, kicking it around, it'll get in the air, and you have all of a sudden have an exposure hazard. Same with dust disposal. It doesn't say how you have to dispose of silica dust, but if the OSHA inspector is walking by and sees your guy out there dumping a vacuum full of silica dust into the dumpster and it's going everywhere, you might gain his attention. Yeah. Which you don't want.
You'll be on my list of fines in the country.
Yeah, we have a few lists of some fines that we'll get to in a minute. The silica rule is based on what OSHA calls a hierarchy of controls. So starting up at the top where it's green, that's what you want to use first. You want to use engineering controls. Engineering controls are things like shrouds, exhaust hoods, anything that collects the dust or knocks the dust down, water spray, that knocks the dust down before it can become an exposure hazard. The next level down is work practice controls. So using your tools, organizing your work in a way that reduces exposures. One thing you can do, like I said, you have the time-weighted allowance. So if there is a job that is going to expose people to above the Pell, one thing you can do after you've done everything you can for the engineering controls is rotate workers through so that nobody is exposed to over 50 micrograms over that 8-hour period. And the last resort is your PPE. So going directly to a respirator is not the first thing you should do and probably get you in trouble.
That should be the last line of defense.
Should be the last line of defense. And actually, we'll get to Table 1 in a second. Table 1 is also organized that way. And here's Table 1. The construction standard has a 2-track compliance system. First one is Table 1. This is basically the most common task that you'll see on a construction site using the most common tools. So they've gone with NIOSH and found out what is the best way to control the dust. And as long as you're doing exactly what it says in Table 1, you're considered to be in compliance. And again, like I said, the reason for this is construction is generally in a non-fixed location. Mm-hmm. And so this way you know that if you're using a hammer drill, you can use a dust extractor and a shroud to collect the dust off there. Or if you're using a power saw, you have to use water. As long as you're doing that, you're fine. It also gives, it also talks about indoors, outdoors, how long you're exposed to it and everything else, and your APF levels. So you can see right there, you have your hierarchy of controls. So as long as you're following those stipulations, you are considered to be in compliance. Now, for circumstances where you cannot fully implement Table 1, there's alternative control measures. So I know some of our guys are from down south, so you're not dealing with as much ice as maybe our northern tier brothers and sisters. Right now, if you are trying to use water with a gas-powered saw in Minnesota, the ice may actually be more of a hazard than the silica dust will be.
You'd get an ice sculpture.
Exactly. And so they also allow for what's called alternative control measures. So you can either do your own air sampling, so bring in, work with a occupational engineer to measure the dust exposures that your people are exposed to, or you can use what's called objective data. Objective data has become sort of like the most common way of complying with this method. And basically what it is using either manufacturer test data or professional organizations. So we've worked with the National Roofing Association. We've given them stuff that they're right now testing it to make sure that our solutions comply with keep the dust down below the Pell. And so as long as you have this objective data, and what that is it is measurements that show that using the method you are using keeps the dust below the Pell. So, and what you have to, when you're using objective data, you have to actually have to be able to show that the conditions you're using it in are better than the conditions that it was tested in. So, for example, for our gas-powered saws, we tested our collection shrouds in a 10-foot by 10-foot enclosed booth. Very few people are using gas-powered saws are going to be in a 10-foot by 10-foot enclosed room. Yeah. And so as long as you are using the same CFM that we were using with the shroud and with better airflow than we had, then you can be considered to be in compliance. You need to have this objective data in your silica control plan. So if you are inspected and they say, well, why aren't you using water? You can open that up and say, Dustless Technologies tested the Dust Bowl, and we're using it in better conditions, and therefore the exposure levels should be below the Pell, and so we're in compliance. Mm-hmm. So that's how objective data works. If you have any questions with that, you can contact me anytime. Just call our main line and ask for me, and I can walk you through specific circumstances. So this shows an example of Table 1. So when someone calls me up and asks me how to comply with the silica rule, first thing I will tell them is, if at all possible, use Table 1. If you can use Table 1, even if it's a little bit more inconvenient, go with Table 1 because you know that you're always in compliance. If not, use the hierarchy of control. Actually, the Table 1 is based on hierarchy of controls, like I already said. And it also talks about whether you're indoors and outdoors. So there are different things you need to do if you're indoors or outdoors. And depending on the amount of time that you are in the 8-hour period that you're doing the activity. So there'll be different APF or the kind of PPE you need to be using. That will change depending on if you're indoors, outdoors, and if you're under 4 hours or over 4 hours. So, in fact, our objective data, if you download our objective data from our website, every product page has a button that says OSHA Silica rule information. And the first page will tell you how to use the tool, the collection shroud, and then it will, if objective data applies, then it will tell you how to do that. And we've purposely formatted it to look like Table 1 to make it easier for you. If you don't know what an APF is, it's basically just the kind of PPE you need to be using. And this shows how it's calculated. APF 10 means that basically you can, that it works in environments where exposures are 10 times higher than your, than the Pell. So if you have questions about your APF, what kind of PPE you need, take the APF factor off of table 1 and go to your safety equipment vendor or an industrial hygienist, NIOSH or OSHA reps, and they'll help you know exactly what kind of PPE you need. Most of your safety equipment vendors will be able to tell you exactly what you should buy.
So my math teacher in high school was right. This one will actually come in handy.
Yes, math does come in handy. Alternative control measures. We already talked a little bit about that, but again, that's your objective data. Make sure it is in your Silica control plan. And you also need to make sure that it needs to be based on the hierarchy of controls as well. So your engineering methods need to be first, and then you use work practice controls. Only then do you go to your PPE. So, so we've already talked about that, so we'll move on. So dust collector requirements. We get a lot of questions about this one. There's a little bit of misunderstanding, misinformation out there. Airflow requirements, you'll hear about the 25 CFM rule in table 1. One thing to remember with that, that is only for handheld angle grinders.
I didn't know that for the longest time.
So for using a handheld angle grinder, a 5-inch, 7-inch angle grinder, for surface grinding, tuck pointing, crack chasing, those kind of things, the 25 CFM rule applies. It does not apply to a gas-powered saw. Gas-powered saws, according to table 1, you should be using water only. Anything else requires objective data.
Like we have.
Like we have, exactly. So all other tasks, you will read, it says airflow required by the tool manufacturer. So as I mentioned on our website, when you download the information document, the Silica rule compliance information, that will tell you the required CFM you need for any of our dust shrouds. So actually both of these here are table 1, are under the 25 CFM rule. But our bit buddy for drilling, it is 19 CFM, is 119 CFM, sorry, is required. So, and that is on that document. So really for all your tools, you really should have that, that information in your Silica control plan, just to make sure that you have it all there if you're asked for it. Filter cleaning mechanism is required for most table 1 tasks that allow dry collection. There is some misinformation out there. You'll often hear that people say that you need an automatic filter cleaning system. That is not the case. You just need a filter cleaning mechanism that allows you to clean the filter without having to open up the vacuum. So beating the filter on the wall or blowing it out with an air hose is not a filter cleaning mechanism. And I don't think kicking your vacuum complies either.
Well, it feels good sometimes.
Yes.
Don't do it.
If you need to get rid of stress, then go ahead, kick your vacuum, but don't do it to clean your filter. For certain tasks, you can substitute a cyclonic pre-separator. So something like Oneida's Dust Deputy, you can attach that between your shroud and your vacuum, and that will also comply. HEPA is not required for most tasks, but there are certain tasks that it is required for. Housekeeping, you're not supposed to use dry sweeping or air blowing methods at all. You should, if you're going to be doing any dry housekeeping, you need to have, excuse me again, sorry. You need to have a HEPA vacuum for dry housekeeping. You can also use wet methods, so you can spray the whole place down and clean it up with a wet dry vac or a squeegee or whatever. But you need to have a HEPA vacuum if you're going to do any kind of dry housekeeping. Cleaning out drill holes. So you don't need to have a HEPA vacuum to drill a hole, but if you take your shroud off and suck the dust out of the hole, that's supposed to be a HEPA vacuum.
So you may as well just start with the HEPA vacuum.
and that's actually what we recommend is that you have at least one HEPA vacuum on site, just because any job site is going to require some kind of housekeeping. Drilling out drill holes, you may or may not do that. You also need, and the third one, cleaning between passes with a walk-behind grinder. That's sort of like housekeeping anyway, so we sort of roll that in there generally. But that is also when you need a HEPA vacuum. One other thing to keep in mind, like I said, slurry, when it's wet, is not an exposure hazard. When it dries, it can quickly become an exposure hazard. So make sure you clean up your slurry. And make sure you dispose of your dust in a way that that doesn't increase exposure. For example, using our Wonder bags that have the closure on it. Before you take it out of the vacuum, you close that off, and then you can take it out without getting dust all over the place. So just try to minimize visible dust when you are emptying your vacuums and disposing of the dust you collect. So for the maritime and general industry, because they're in a fixed location and they have fixed processes, set processes and everything else, they have a slightly different regime that they comply with. It's basically similar to our alternative control measures.
Looks complicated.
Yes, it's a little bit more complicated, but the thing is if you are talking to somebody that or you are somebody that has exposure hazards in a factory setting, then you can set up the dust collection hoods, the work practice controls, you can do the exclusion zones, all those kind of things. You can set those up once and you're pretty much set there. So you set it up, you're supposed to do a series of testing. If you're below the action level the first time, then you don't need to. So if you're below the 25 micrograms, you don't need to do any further testing. But if you're above the action level but below the PEL, you need to test every 6 months until you have 2 consecutive tests from 7 days to 6 months apart. If you hit that target, then you don't have to test until you change something.
Wow.
And so that's why it's a little bit more complicated for industry and maritime, because they can set these things up and they can leave them unchanged for a long period of time. So basically, with engineering, with the maritime general industry, excuse me, you use a hierarchy of controls. You make sure that your people are trained. They know who the competent person is. That's one person that they will often, that's one question the inspector will often ask, is who's your competent person? If any of your employees they happen to walk up to and ask that question doesn't know, then you can get a ding on your inspection for that. So make sure everyone knows who the competent person is and where the Silica control plan is.
And as tempting as it is to make jokes about who the competent person is, you have to have an official competent person.
Yes, you can joke all you want until the inspector shows up. But again, with PPE, make sure you use all feasible controls first, and then use that after. So what happens if, and I've heard a few people say, well, OSHA never inspects us. But what happens if you do get inspected? First of all, OSHA can come into your life in many different ways. They can just be driving by and decide they're going to stop in and inspect you. But most often what happens is somebody gets hurt on the job site, and depending on the injury, you will have to call OSHA. And OSHA will come in, they will do an inspection. And so even if you never normally get inspected and would never normally attract their attention, all it takes is somebody to get injured, and all of a sudden they're in your face and in your chili. So you might as well be ready for them. because if you look at some of these, this is a fine in August of 2018. This is a fine under the new Silica rule. It was a bridge contractor in Virginia, got over a $300,000 fine for willfully neglecting to implement silica dust control. So he had guys out there with jackhammers, with no dust suppression, with no respirators, with nothing, and so they got hit with willful violations. $300,000. I don't know how many of you could absorb a $300,000 hit to your bottom line. I know my company would have a hard time doing that. So.
And if you sign up for our newsletter, there's a spot on our website to do so. We're going to start publishing these to make them easy to find.
So now, I will say that the silica violations are not as common as fall protection, lockout, tagout, the trenching hazards. Those things, they get fined a lot more. There are a lot more violations there. But you also need to realize that even if the injury that's happened on your job site did not involve silica, they will come in and they will roll additional fines on top of each other. So most of these fines are for multiple violations. And every violation that they see, every worker that is exposed to silica above the Pell could be an additional fine. So just keep that in mind. This is before the construction standard went into enforcement, but it was still a $273,000, almost $274,000 fine. Wow. So again, you know, we don't like to rely on scare tactics. Again, I prefer to say, take care of your employees, make sure that they have the proper equipment, the best equipment, and that they're working in a safe environment. But you also need to realize that there is a pretty steep downside if you decide to ignore any of OSHA's safety rules. Okay, so this is just a slide showing a few of the things that some of our products, all of them are either Table 1 compliant, or we have objective data to show that they are compliant.
And they're universal solutions.
Yes, the biggest thing with us is if you like your skill saw and your DeWalt grinder, you don't have to give up one or the other to have a good solution. We design everything to be as much as possible a universal fit. We also have vacuums, sealed HEPA vacuums. You got to realize that just slapping a HEPA filter on a shop vac doesn't make it a HEPA vacuum. It may comply with the letter of the law, but it is not really, you're not really doing any favor. The dust will bypass. If it's not sealed, the dust will bypass the filter and come out the exhaust and actually be more of a hazard than it was before. Also, if you visit our website, you can go to our interactive OSHA Silica Rule Compliance tool. Basically, you can click on that and you select the job that you're doing, the kind of tools you're using, and it will give you an OSHA Silica Rule Compliant system. It will recommend, if you need 2 vacuums, well, it'll always recommend a HEPA vacuum because, like I said, everyone's going to be doing housekeeping, so you might as well have a HEPA vacuum. But for the 2 vacuum systems, it will usually do 1 HEPA, 1 non-HEPA. So this is just a little bit more information on where you can find more information on the Silica rule. So let us know if you need any more information, and I'll be happy to help you out.
I will point out that we are recording this presentation, and so the recording as well as the slideshow will be available on our website after this. But with our last few minutes, I'd like to open up the floor to anybody that has any questions out there. You've got a pro, so let's hear them. I know you've got them.
You see the chat? Okay, Megan will read me anything that happens to be in the chat.
Okay, we've got one question here. It says, what is the CFM rule for drilling?
CFM rule for drilling is manufacturer's recommended CFM. I know that doesn't quite answer your rule. I can tell you for our bit buddies, it is 119 CFM.
Yeah. Like if you're using an accessory like this, where you're drilling up to 1 3/8" diameter hole, the recommendation is 120.
Yes.
CFM.
And so you basically just, again, that will be on our website. You go to the product page. So you just go to the Bit Buddy product page. There'll be a yellow button there that says OSHA Silica Rule Info. Click on that and it will tell you exactly how much CFM you need.
Right. Because it depends on the different size drill that you're using, the different bits that you're using, what application, what materials you're drilling into. So it gets a little convoluted there, but for the most part, we've got solutions for them on our website.
The 4 and the 1 3/8 are both 120 CFM. I think the 8-inch is bigger because it requires a little bit more air, a little bit more suction to keep it on the wall.
Right, right. The next question is, can I get the Dustless solution page emailed to us? If you mean the Dustless solutions, we can email the digital brochure, of course, but we have the OSHA Silica web tool, and that's a live tool that you click on to figure out what shrouds and what other products you need.
We can, actually, if you just go to www.dustlesstools.com, it is on the banner.
Yeah, yep, right on the front page.
Just right on the front page, just click on that and it'll take you right to it.
I've got a question that says, thank you very much, very helpful. Will this recorded video be available online? Yes, we will publish this video as well as the PowerPoint on our website. Probably give me a couple days. I'll get it on there.
Hey, Megan.
Dave Raymond. Hi there. Just a comment that, usually compliance is a lot less money than the fines that are levied. So, usually when you go in to talk to a customer, they listen, it's going to cost you $5,000 to become compliant. It's going to cost you $50,000 or $100,000 for a fine. I mean, it's pretty easy math.
Exactly. You can also throw in there, how much does it cost to hire a new employee? Usually more than $5,000 to get them fully trained and up and going. So you might as well pay the $5,000 to make sure that you don't get them sick.
Right. Take care of the ones you have.
Megan, can you hear me? This is Dan.
Hi, Dan. Go ahead.
There was one page you had in that PowerPoint that had the CFMs needed for each tool. That was really good. Do you have that too? All that information was on one page for the Bit Buddies, Dust Bowls, about how many CFMs you needed.
Yeah, that'll be included in the PowerPoint, but I can email you that individual page if you prefer.
That'd be great. That was really good.
Yeah. I don't recall if it had all of the CFMs. It did have the 25 CFM rule. But again, if you go to the product page and click on that OSHA Silica rule information, every single one of those documents will have the CFM required for the individual shroud.
Okay.
Well, if there's no other questions, we'll tie this up. I thank you all for joining us. Like I said, this will be published on our website in a couple of days, but don't ever hesitate to call in if you have any questions, write. We can get you in touch with your local reps, or you can deal directly with us here at the office. Thank you very much, and thank you, Brent.
Thank you.
Thanks, guys. It was great.
Thank you.